Hello everyone, thank you for joining our webinar today, Soil Blending with RemOx ISCO Reagent, Potassium Permanganate, with our guest speaker, Mr. Steve Markusek from Redox Tech LLC. Just a few items before we get into the webinar. Here's a look at our 2016 webinar series that is remaining. In September, we will have slow-release chemical oxidants for passive in-situ treatment of chlorinated ethylenes and 1,4-dioxane, with Dr. Pat Evans of CDM Smith presenting. October 17th, we have safety and handling of permanganate with Carus's Mr. John Bull presenting. And in November, we will have permanganate and persulfate for in-situ chemical oxidants and water treatment applications with Mr. Bruce Marvin from Geosyntech Consultants presenting. If you're interested in joining any of these webinars, please let me know and I will get you added to the list. Also, we send out 2 newsletters every year as well as some various email blasts. If you are currently not on that emailing list and would like to be added, please let me know. A few housekeeping items. We do have everyone on mute to help cut down the background noise. There is a feature in GoToWebinar where you can type in your questions, so please feel free to type in your questions as you think of them. We should have time at the end for question and answers. If for some reason we do not specifically get to your question, GoToWebinar allows us to see the question asked and your contact information, so we will follow up with you directly. Also, we will email out a PDF version of the presentation today to all attendees. So be looking for that from myself either this afternoon or tomorrow. And with that, I would like to introduce Steve. Mr. Markusek has a geological engineering degree and an MS in hydrogeology from the University of Waterloo. He is a manager at Redox Tech LLC and has significant experience designing and managing various remediation projects. His experience includes using aerobic, anaerobic, and co-metabolic bioremediation, as well as in-situ chemical oxidation. He has experience using a variety of different amendments, including base and iron catalyzed persulfate, potassium and sodium permanganate, ABC, ABC+, and others. Mr. Markusek has extensive experience mapping, implementing, and assessing both pneumatic and hydraulic fracturing. His experience also includes estimating, designing, and managing various hydrogeology tests used for site assessment and remediation design. In addition, he has extensive experience with LNAPL modeling to determine recoverability and estimate recoverable volumes to assist in remedial design. And with that, I would like to welcome Steve.
Okay, thanks, Liz. Good morning, everyone. Appreciate everyone joining us this morning. As Liz mentioned today, we're going to be talking about soil blending with potassium permanganate. But before we start with that, just a couple of notes about Redox Tech. For those of you not familiar with our company, we're a remediation contractor that provides turnkey services, and what I mean by that is that not only do we have the personnel and equipment available to implement this remedial work, we also have PhDs and engineers on staff that can help our clients design remedial approaches for their sites. The company was founded in 1995. We've got offices scattered throughout the United States, but our headquarters is based out of Cary, North Carolina. To date, we've done over 1,400 projects. We're not biased towards any approach. We have experience with biological, chemical manipulation. We do both reductive and oxidation approaches. We have hydraulic fracturing capabilities with our geoprobe rigs. We also own and operate our own in-situ soil blending equipment. So when we get involved with soil blending, we don't sub out this work to other vendors. We do this all in-house. In the spring of 2013, we entered a co-marketing, co-distribution agreement with Carus, and this has become a very mutually beneficial agreement. A lot of the products that we manufacture can now be purchased directly through Carus. The way I have this talk broken out, I thought we'd start off just talking about the concepts of soil blending, go into the different types of equipment that are available out on the marketplace, and then specifically talk about RemOx ISCO Reagent, which is Carus's potassium permanganate, and how it relates to soil blending. And then I've got 3 separate case studies that I'm going to show that kind of illustrate the type of projects we get involved with and what kind of results you can expect to see. The soil blending is pretty simple. Basically, we're just mechanically mixing the soil so that we homogenize it and uniformly distribute whatever amendment it is that we're trying to deliver to the subsurface. Our production rates when we've done these projects are comparable to dig, haul, and backfill. One of the big advantages to soil blending is that there's going to be no long-term liability associated with waste disposal. Since we're treating everything in place, you don't have to worry about that waste stream that you do with dig and haul. Our costs, they can be anywhere from 2 to 10 times less expensive than dig and haul, and that's going to be based basically on how big of a project we're working on, what types of soils we're dealing with, how deep we have to go, and how much amendment that we're applying. One of the misconceptions with soil blending is that you need special permitting, and that's not the case. As long as we're working within the area of concern, we're not going to need any special REC or TSD permits. And then the question becomes, when would you consider using soil blending? Well, with our the excavator style blending heads, basically anywhere you can dig and haul, you're going to be able to soil blend. But in particular, you're going to be looking at soils that are really cohesive, low permeable soils that aren't going to let you distribute an amendment using other techniques like injection. You also might want to consider soil blending in areas where you have high volumes of amendment. Let's say you're doing a soil stabilization project and you want to add 5 weight % by Portland cement. Soil blending is going to be a lot more efficient of an approach than trying to inject those kinds of volumes. And then finally, your time frame might be a key component to deciding whether you want to do soil blending. If you've got a site closure on the horizon, you want to get the cleanup done quickly, but soil dig and haul isn't an option, soil blending is probably going to be your next best bet. One thing I do want to point out is that because we are tearing up the soil fabric, we are going to be affecting the geotechnical properties. So the compressibility, shear strength, things like that are going to be affected. So depending on what your end use is and the time frame, you might want to consider soil stabilization as part of that remedial design. And that's just going to be dependent on what your end use is going to be. So I've got soil blending broken out into 2 different classes of equipment. You've got your deep soil augers and mixers, and these are great for deep applications. These are large style equipment that basically they're mounted on crane style equipment, and basically you're rotating augers down into this formation and blending in your amendment as the auger goes up and down. Obviously this type of equipment needs a lot of space to operate. It's not going to be as efficient for large areas, and because of the size, your mob and demob costs are going to be quite high. Other style soil blender would be the excavator style blender, and these are the types of equipment we use and what I'm going to present today. These are depth limited. Typically we're working to about 25 feet maximum, but we can go deeper if we bench. We've done projects as deep as 35 feet. We even have a project later this year that we're going to go to 45 feet. And to do that, we're going to be benching down, and basically that means our blender is actually entering into the excavation to get to those deeper depths. This equipment is pretty efficient to blend large areas. Our construction rates vary from 200 to 600 tons per day. Again, that's going to depend on how big of a project we're dealing with, how deep we have to go, what the soil type is, and how much amendment we're adding. Again, because it is on an excavator, it's a smaller footprint than the large crane styles, and obviously our mob and demob costs are going to be a lot less because of that. But these are just the different styles of blenders out there on the marketplace. There are others as well, but the big difference between all of these blenders is, well, there's 2 major differences. One of them is power, and the other is going to be the size of that blender head. On the left, you've got the Alube blender. This runs at about 90 horsepower, can reach about 16 feet below grade. It's not going to be very efficient in very cohesive and plastic clays. You're definitely not going to be able to plunge that to depths of 16 feet. You're going to have to manage that in smaller lifts. The Lang tool, which a lot of you might be familiar with, we own one of these pieces of equipment. This is a much more robust blender. It's running at 200 horsepower. We've been able to get down to about 25 feet with that extension. And then after using that equipment for a little while, we decided to go ahead and build our own blender that would be more suited for what we did, and that's the blender here on the right. We went with a 2-drum design. Each one of those drums has its own hydraulic motor that runs it. They're load sensing, which gives our operator an advantage as one, excuse me, as one of those drums starts hitting into native material, the torque increases, RPM decreases, starts cutting into that native material while the other drum continues to spin and mix. The entire unit's running at about 295 horsepower, which is run off of an independent hydraulic power pack that's mounted on the back. One of the other advantages of this head is, as well, is that we can actually swap out these teeth, put carbide bits, and we're able to blend into weathered bedrock as well. Brief note about remediation costs. Typically, we're running at about $15 to $20 a ton to blend. As projects get bigger, you're going to gain some efficiencies in scale, so the price will come down. But what the big driver is going to be on a lot of these jobs is how much amendment you're using. We've done projects where we're adding as little as $5 per ton of bulk soil. These would be types of projects where we're adding just maybe a little bit of quicklime for stabilization. In other instances, you could be over $60 a ton. This would be an oxidative approach where you've got soils that have really high total oxidant demands that require a lot of oxidant. Even so, the combined cost is still going to be pretty comparable to dig and haul, if not less. And then the big advantage there is that with soil blending, you're not going to have that long-term liability within the waste stream. So even if the costs are comparable to dig and haul, a lot of times it's a more attractive option for our clients. So brief note on RemOx S ISCO reagent, which is Carus's potassium permanganate. For those of you not familiar with this product, it's a bright purple oxidant. I have a photo there in the bottom right that kind of illustrates it. It's a single component oxidant, which means you're not going to have to activate it or catalyze it. It arrives as a dry powder. We can blend it in place with water, and as soon as we're done blending it, the chemistry begins. It's not pH influenced by pH, so if your soils are a little acidic or basic, the chemistry is not going to be effective, nor is the permanganate going to cause any corrosive effects, which is nice on the equipment. And if you have any utilities nearby, you're not going to have to worry about corrosive issues with that as well. It's somewhat of a long-lasting oxidant, depending on how much excess you put in there. It will stick around for a while, start taking care of any contaminants that might be desorbing from the matrix. Also, if part of your remedial design is to allow some of this permanganate to leach down into some underlying zones, this is a good oxidant for that type of application. And then finally, the color is a big bonus. Because it is a bright purple, you can visually see when the oxidant is completely mixed within the soil. Also, it can be used as a tracer. If it's leaching down and migrating, you can spot it in monitoring wells pretty easy. And I have a case study that shows that effect. And then once the purple is gone, it's also an indicator that the oxidant's been consumed. So it's a really good oxidant to use for some instances. With some of the keys to success with an in-situ chemical oxidation approach, obviously it's a contact chemistry. And so with the soil blending, you don't have to worry about that parameter in your remedial design. We know we're getting the contact, we know we're getting the distribution, so then you need to start worrying about whether your delineation is accurate and whether you've added enough oxidant to take care of all that contaminant that's there. One of the things we recommend to all our clients is that they do TOD, or total oxidant demand testing, on site soils. This is where you collect a soil sample, send it into the lab. The lab's going to mix it with an excess amount of oxidant, allow it to sit for about 72 hours, and then titrate off any excess oxidant that might be there. And they're going to provide you with a number that basically is an indicator of how much oxidant you're going to need per kilogram of soil. This is just a guideline. This isn't an end-all be-all number. And so we typically recommend that you collect a number of these samples and have them analyzed. You'll oftentimes see a variability across your site. And you certainly want to use that as a starting point in your remedial design. Carus Chemical, they offer this service, and there's also some other labs out there that also do it. Now I'm just going to go into my case studies. I've got 3 different case studies. Each one's kind of unique, and hopefully you get something out of it. The first one's an industrial site in Illinois. This was a Vadose application in a pretty tight clay and silt. We were treating from 4 to 8 feet below grade, so we had to dig out the top 4 feet, and we blended from 4 to 8 feet. It was a very limited area, only 500 square feet. And one of the reasons I like to show this case study is because this was one of these instances where they had a really high cleanup objective. They only had to reach the soil saturation limit, which was at 1,300 parts per million. Starting concentrations were as high as 10,000 parts per million. So the consultant decided they could just blend in some peroxygen oxidant with a conventional backhoe, hoping that that would be all they need to do. Unfortunately, after they did that, their remaining concentrations were still as high as 7,000 parts per million. So here's just a graph showing that data. You can see the range of concentrations after the initial mixing attempt is still pretty high. Ranges from over 7,000 as low as 2,000 parts per million. And even if you didn't use an oxidant, you would expect that if it was properly homogenized, that range should be a lot tighter. You should be able to, those concentrations should have averaged out a little more. So this is when we got involved. We decided to come in there with our soil blending equipment, use potassium permanganate just because we didn't want to worry about any activation chemistry. For this site, we applied just under 2,700 pounds of potassium permanganate. And in this case, we just went with a stoichiometric calculation. Because they had already applied an oxidant, we felt a lot of the natural oxidant demand was already gone. So we just did a stoichiometric calculation and then added a factor of safety, knowing that the cleanup standard was pretty high. So we did the work in a single day for $17,500. That price included remob, demob. It included all the labor, all the chemicals, and the equipment on site. So here's the results from that blending. You can see all the concentrations came down to roughly about the same point. There's about 600 parts per million, which was half of the cleanup objective. So at that point, they were able to close out the site and apply for an NFR. The second case study, this was another industrial site in the Midwest. This is a site where they had both TC and DC contamination in both soil and groundwater. It was a glacial till, some interbedded sand layers. TC in the soil was as high as 1.2 million parts per billion before any treatment was done. The consultant did do a little bit of dig and haul in the source area. They also installed an SVE system to try and remove some of that source zone contamination, but unfortunately there wasn't enough permeability. They weren't able to get much mass out of there. So they decided to go with potassium permanganate soil blending. This was selected over soil stabilization and dig and haul because it ended up being a lot less expensive, and it provided them that permanent treatment. They didn't have to worry about the waste stream. So we completed this work for roughly $50 a ton. Total amount of soil that was blended was just under 17,000 tons. We were treating from 2 to 25 feet below ground surface, and to date, this is actually one of the largest soil blending projects we've completed. And this just gives a little overview of the site. We had two separate areas, a smaller area to the north, and then this larger area towards the south. And if you can make out in this south plume area, we've got these green boxes. For all of these, whenever we get involved in a large soil blending project, what we typically like to do is subdivide it out into these smaller, more manageable cells, and then we systematically address each one of these cells independently. And this provides a lot of advantages. It's easier to manage your production rates. It allows us to adjust our loading based on soil contamination. So as we get towards the center of the plume here, we were able to add more permanganate. As I had mentioned, we're treating from 2 to 25 feet below grade. For that type of a thickness, what we did was we actually excavated from that 2 to 14 foot zone, stockpiled it, blended from 14 to 25, backfilled, then blended from 2 to 14. And that also provides a couple of advantages. For one, it's a much more efficient process. You wouldn't think so, but it's more efficient for our operators to blend a shallower lift than to try and blend from 2 to 25 feet in a single lift. It also allows us to make sure that our vertical distribution of oxidant is appropriate as well. So we applied just under 168,000 pounds of permanganate. This worked out to be an average dosing of about 5 grams per kilogram. This was based on TOD samples that were collected from the site. Like I said, we did vary the dosing, so as we got towards the center of the plume where the concentrations were higher, we did increase that dosing. The entire project took just under 50 days to complete. After completion, the consultant took one confirmatory sample from each one of those cells. They all came back as non-detect, so very successful project for us. And here's just some photos. This is the blender addressing that lower zone. You can see the bright purple there as the blender is mixing it in. Once that's completed, the upper soils are backfilled and additional permanganates added and then blended to that upper cell as well. So the final case study I have, this is a US EPA site in Rhode Island. This was a former drum storage area, and it was kind of a unique site. The upper 10 to 12 feet at this site was clean, so we had to excavate that and stockpile it. And then we blended permanganate from that 10 to 12 foot zone all the way into the fractured bedrock, which was at about 18 feet below ground surface. The loading rates here were based again on TOD analysis, and all this work was completed for $70 a ton. So this is just an overview of the site. We did the blending in the former drum storage area, which was actually on the top of a hill in a wooded area, a unique location. Total area was about 8,500 square feet. Again, we took that area, subdivided it out into some smaller, more manageable cells that we could systematically address one at a time. Well, let me go back for a second. One of the unique features of this site, too, is that there was a large dissolved phase plume that migrated downgraded. And one of the goals here was to allow some of this permanganate to leach down into that fractured bedrock and then migrate. So there was a number of monitoring wells which were installed around the soil blending area that were monitored for permanganate as we did the work. Here's just some photos. This upper photo here just showing that the top 12 feet being excavated. You can see this site had a lot of these large boulders and cobbles that we had to deal with. For most soil blending projects, we have an excavator on hand that works in tandem with our soil blender, and the excavator does a lot of things. It moves soil as we need it to. One of the big keys is that we actually pre-mix the soil a little bit with the blender just to make sure things like this aren't buried. When we come across those, we want to dig them out. Otherwise, this could damage the soil blender head. Here we're applying our first super sack of permanganate into the first cell. The permanganate, Carus can send this to you in 1,000 or 2,000 pound super sacks. And what we like to do is try and design our cells so that even amounts of bags are applied to each cell. And this just gives our field crews a little more, a little easier ability to manage the amendment. Some more photos here. This is just the excavator just pre-mixing that cell to make sure that nothing's buried. And then at the bottom here we have the soil blender blending with the excavator on standby. After the first day, we had completed the first 3 cells. About 300 cubic yards of soil was contaminated, 2,000 pounds of permanganate was added. After day 5, we had completed 3/4 of the cells, and at that point we started to see permanganate show up on the along the western edge of the area in the fractured bedrock. By day 7, all of these cells were completed. An additional well started to show permanganate, and then by day 12, a total of 7 monitoring wells, all located in the north and western edges of this soil blending area, showed permanganate that was showing up. At this point, the client took some soil samples. All those soil samples came back clean, non-detect. And then prior to backfilling the clean soil, what we did was we actually placed some horizontal perforated piping in this area with some standpipes, which allowed the consultant to continually add a dilute solution of permanganate, which would continually feed this down gradient soluble plume. And I believe they're still doing that to this day. So in summary, I just want to say blending with permanganate is a pretty cost-effective method for delivering oxygen into your source areas. One thing I do want to point out, these case studies all reach their cleanup objectives in one application, but there are cases, especially if you have DNAPL or free-phase products sitting there, it may be more appropriate to plan on multiple applications, especially if you're not quite sure on how much mass is there. With DNAPL, as you're blending, that gets spread out, and it's kind of hard to plan for appropriate amounts of amendments. So sometimes it's more efficient just to plan on multiple blending approach. And then finally, like I mentioned, because we are tearing up the soil fabric, you are going to affect the geotechnical properties. And depending on how much time you have, you can certainly let that reconsolidate on its own, But if you have an end use that you have to worry about, soil stabilization may be something you should consider as part of that remedial design. And on that note, I want to thank everyone's time. If you have any questions, I'd be happy to answer them.
Great, thanks, Steve. So here's just a quick look again of our remaining 2016 webinars. If you're interested in attending any of these, just let me know. I'll get you on the list. Also, if you're not currently receiving our newsletters or email blasts and are interested, let me know. And just one last comment, we will send out a PDF of today's webinar to all attendees, either this afternoon or tomorrow. There's a feature in the GoToWebinar where you can type in any questions that you have. We'll give people just a couple seconds here. Doesn't look like there's any questions. Here is a list of our contact information. We have the Carus contacts here on top and then Redox's contacts on the bottom. So if you think of any questions, please feel free to reach out to Steve or any other members of Redox Tech. And with that, we would like to thank Steve again for presenting, and thanks everyone for attending.